Hello and welcome. Today we are diving into what is probably the biggest headache for anyone getting started with Docker, and that's networking. We're going to take all that confusion and turn it into complete clarity. So let's just jump right in with the number one problem you're almost guaranteed to hit. So picture this. You've got your web app in one container, your database in another. You run them, they both start up, everything looks perfect. But then your app tries to hit the database and connection refused. Nothing. It's so frustrating, and we've all been there. So what is actually going on?
Okay, to solve this little mystery, you first have to understand that this isolation, it isn't a bug. It's actually one of Docker's most important features. Once you really get why containers are separated by default, you'll have the key to connecting them the right way.
Let's try an analogy, because this really helps. Think of your Docker setup as a big apartment building. Every single container you launch is like its own private apartment. It's got its own walls, its own plumbing, its own front door. You can't just wander into your neighbor's place, right? This separation is totally intentional, and it's what makes containers so powerful.
Now, the technical kind of nerdy term for this private apartment is a network namespace. This is a feature that's built way down deep inside the Linux kernel. It basically gives every container its own little network world, its own IP address, its own routing tables. Everything is completely separate from the host machine and from all the other containers.
So, how do we connect these different apartments? Well, Docker gives us a few options that fit our analogy perfectly. The default bridge network, that's like a shared hallway. If you're on the same floor, you can talk to each other. The host network is like a shop on the ground floor with a door right onto the street. It uses the host's network directly, so there's zero isolation. And then you have the none network, which is basically a secure bunker. Completely cut off, no network at all.
All right, so let's just nail down the three big ideas here. First, isolation is the default. Every container is in its own bubble. Second, they can't just magically talk to each other. You have to set up the communication by putting them on the same network. And third, and this is the real magic trick, if you put them on the right kind of network, you can just use their names, like database, to connect, and it just works. We're going to see how in just a second.
And that brings us to the villain of our story today, the default bridge network. It's the one Docker uses if you don't tell it otherwise, and honestly, it's the source of pretty much all beginner networking pain. If you pop open your terminal and type Docker network ls, you'll see these three networks are just there. They're created automatically. And anytime you Docker run a container without that little dash network flag, Docker just silently plops it right onto that default bridge network.
So let's see this trap in action. We launch two web servers. They both land on the default bridge. Then we try to ping one from the other using its name, web server 2. And bam, failure. Name or service not known. This is it. This is the exact error that trips everyone up. They're on the same network, but they might as well be on different planets. Now you could get clever. You could run docker inspect, find the container's internal IP address, and ping that directly. And yeah, that'll work for a little while. But here's the killer problem. Those IPs are not stable. The next time that container restarts, it'll probably get a new IP, and your whole application breaks. What we need, is to connect using a stable, simple name. And hey, don't just take it from me. The official Docker documentation could not be more clear about this. They literally call the default bridge a legacy detail and flat out say it's not recommended for production use. Why? Because it's missing the single most important feature you need for a multi-container app, automatic service discovery, or DNS.
So, if the default network is our villain, then who's the hero? Well, let me introduce you to the user-defined custom bridge network. This is the answer to all our problems, and you won't believe how easy it is to use.
The solution is just three ridiculously simple steps. 1, you create your own network with Docker network create. 2, when you launch your containers, you just tell them which network to join using the dash network flag. And 3, that's it. You just communicate. It is honestly that simple.
So when we run that same ping command, ping database, it works. It just works. What's happening is that on these custom networks, Docker runs a tiny little built-in DNS server that automatically maps the container's name, database, to its current internal IP address. This is the magic that makes everything click. So let's just recap why custom networks are just so much better. First, you get that automatic DNS. Your container names just become host names. You get way better isolation because only the containers you explicitly put on this network can talk to each other. You totally get rid of all those IP address headaches, and as a bonus, you can even connect or disconnect containers from networks while they're running. It's a huge win all around.
Okay, theory is awesome, but let's put this into practice. Let's look at a real-world, production-style setup. We've got a web app that needs to be seen by the public, and a database that absolutely should not. Now this is where it all comes together. Look at the web app command. We use the -p flag to publish its port. This connects the port inside the container to a port on the host machine, making it accessible to the outside world. But now look at the database command. Notice what's missing? There is no -p flag. The database is completely sealed off from the outside. The only way to reach it is from inside that same custom network. This is so important for security.
And the beautiful result of all this? Your application code becomes incredibly simple and clean. Your connection string doesn't need some fragile, hard-coded IP address. You just use the service name, mysql-db, as the host name. It's simple, it's reliable, and it's secure.
All right, we have covered a ton of ground. Let's wrap things up with a quick reference guide. We'll go over the essential commands you'll need and the common mistakes to watch out for.
So here's your handy cheat sheet. You've got ls to list your networks, create to make a new one, that's your new best friend. Inspect is great for troubleshooting, it shows you exactly what's connected, and connect and disconnect lets you manage things on the fly. These are really the commands you're going to be using day in and day out.
Now, let's quickly go over the big mistakes so you can avoid them. Number 1, and we've hammered this home, using the default bridge. Just don't do it. Always Docker network create. Number 2, using localhost in your app's config. Remember, localhost inside a container means that container itself, not some other container. Always use the other container's name. And finally, please don't publish your database port unless you have a really specific, good reason. Keep your backend services internal.
So, if you walk away remembering only one thing today, let it be this. Rule number 1 is to always create a custom bridge network for your applications. It is the foundation for building secure, reliable, and scalable systems with Docker.
Okay, so you've totally mastered connecting a few containers. But what happens when you have 10 containers or 20 in a big microservices setup? You know, creating networks and running all those commands by hand gets old really fast. And that is exactly where the next tool in your toolkit, Docker Compose, comes into play. So, are you ready for that next step?
We are absolutely going to cover Docker Compose in our next explainer, where we'll automate this entire process. So make sure you're subscribed so you do not miss that. Thanks so much for watching.